So my name is Basim Alabd. I have been working with radar technology, and my work is time frequency synchronization for chirp sequence-based radar systems in interference scenarios. As motivation for this work, we have multiple radar nodes in the environment, and two, they would like to communicate with each other, and they want to detect a target in the environment. For a complete system, we use a preamble for the synchronization, and we use a couple of chirps here to make the sensing for radar, and just a limited bandwidth for the communication. So in multiple scenarios, when we have different signals, then we will get overlapping between those signals. For radar, it's a major problem because it will cause kind of raising for the noise level or ghost target. For communication, it can be limited because we use just a narrow bandwidth here. Even though we wanted to investigate the influence of the interference on the communication data, for that we can apply one transform, which is fast quadratic phase transform, to detect the slope of each signal that we have. And we see here each peak represents one signal. Then we can do a correlation between a reference signal with the transmit frame that we get, and we get peaks from up and down chirps. If we calculate the distance between up and down peaks, then we are able to define the frequency shift. If we calculate all the differences between this frame, we can calculate the time shift. For this investigation, we have been doing one measurement in baseband with 1 gigahertz, and with FPGA from Xilinx company, and we investigate the frequency and time synchronization without interference. So that means just with one signal, without the three ones here. And then we get a maximum peak for the time synchronization. And here for the frequency synchronization, everything works properly. On the other hand, if we have one interferer, then the time peak will drop, and the frequency synchronization will be a little bit worse. If we have three interferers at the same time, we can say that for three interferers, it will not work so much well for the frequency synchronization, and the time synchronization will be 1/4. So for conclusion of this work, I can say that we have developed a method for interference detection in communication-assisted chirp sequence radar. We used FQPT for detecting the slope of each chirp that we have sent. The correlation was done to detect the time and frequency shifts, and we have done also some measurements with Xilinx FPGA to detect the interference influence on the communication data in this signal. Thank you.